Grade 8 Math, number 7.2e, solving linear equations. I'm going to write linear equations for 3 consecutive even integers. To solve an equation with the same variables on both sides of the equal sign, first, we see if like signs need to be combined on their own side of the equal sign. Next, we use inverse operations to isolate the variables step by step. The inverse operations, of course, are you add if there's subtraction, you subtract for addition, we multiply for division or divide for multiplication. The inverses. What we do to one side of the equal sign should be done on the other side of the equal sign. So let's say we had this. This is our equation. And you can see we've got a 10x on one side on the left and a 6x on the right side. So we've got variables on both sides of the equal sign. All we have to do is start doing inverse operations to start isolating the x. We have a positive 3, so we could take away a negative 3, see? So we could take away 3. That creates a 0 pair right here, and it cancels it out. And then 11 take away 3 is 8. So now our equation says 10x equals 6x plus 8. Now we can take 6x away from both sides. This is a positive 6x, so if we take away 6x, it's going to create another 0 pair. And now our equation has 10x minus 6x on the left, so we have 4x. We drop down the 8, and we've got 4x equals 8. Now, because 4x is a multiplication problem, 4 times x, we divide as the inverse to both sides. 4 divided by 4 is 1. There's our friend the invisible 1. And 8 divided by 4 is 2. This whole equation came out that x is equal to 2. See? Just kept doing inverse operations back and forth. So Bob wanted to find 3 consecutive integers whose sum was 6 times the first of those integers. Let n represent the first integer. And I know this sounds confusing, but follow along. This will get easier. So the first thing we notice is it says even consecutive integer. Well, consecutive means following continuously in sequence, in order. So that means they're integers that are in order. Consecutive integers in order would be like 1, 2, 3, 4, 5, or negative 8, negative 7, negative 6, negative 5. Remember, integers are negative or positive whole numbers. So for them to be consecutive, they would be in order like that, see? So even consecutive integers would be 2, 4, 6, 8, 10. Odd consecutive integers would be 1, 3, 5, 7, 9. So how do we find out what 3 consecutive even integers whose sum was 6 times the first of those integers? How do we find out what that is? Well, before we get into the even and odd, let me show you just consecutive integers. If we needed an equation to just find regular old consecutive integers, it would be the original number plus that number plus a 1 plus that number plus a 2. So if the original number is a 1 and we want the next consecutive integer or next consecutive number, we're going to add 1 to this one because that would be the next number, 2. And to get the consecutive integer after this one, we would take this original number and add 2 to it. That would give us a 3. Then we'd have 1, 2, 3. Well, what happens when we're doing even and odd consecutive integers, we need an equation like this. Then instead of saying plus 1 and plus 2, it says plus 2 and plus 4. This will help us find the consecutive integers, whether even or odd. I know these are even numbers, but that's got nothing to do with it. Whether they're even or not odd, both even and odd consecutive integers are going to skip a number when they're consecutive. We add the original number to the original number plus 2 to the original number plus 4. And that skips over the odd number, see? The original number n was 8. To get the next even consecutive number, we'd add 2 to it, right? Because the next number would be a 10, the next even number. So that would be an 8 plus 2, and so on, then an 8 plus 4. Now, it also said the sum was 6 times the first of these integers. So that means if it says the sum was 6 times the first of those integers, it's 6 times the original number. So it's going to be 6 times that n, see? So we end up with this equation. N plus 2 plus n plus 4 is going to equal 6n. We combine the like terms. How many n's are on this side of the equal sign? We ignore the 6n for now. We combine like terms on each side of the equal sign to each other. There's 1, 2, 3 n's, 3n, and a 2 plus a 4 is a 6. So our equation says 3n plus 6 equals 6n. See, now we put him in. Now we can do our inverse operations to isolate n to find out what it is. So because this is a positive 3n, we can take away 3n, and that's going to create that 0 pair, isn't it? Now our equation says 6 equals 3n, because 6n take away 3n is 3n. See, we took it away from both sides. So now because 3n is a multiplication problem, the inverse of that would be division, so we divide both sides by the 3. That creates our friend, the invisible 1. And 6 divided by 3 is 2. We know n is 2. So if we know n is 2, we can plug it into this original equation and figure out what this is. So if n is a 2, two plus 2, that's a 4. So we know the n is 2. This is a 4, this is a 6, and 6 times 2 is 12. Our consecutive integers are 2, 4, and 6, and look, when we add them together, they do equal 12. So now, we know that the consecutive integers are 2, 4, and 6. What we did was we just plugged in this 2 as the n, see? And the sum is 6 times that original number 2, so we know that's 6 times 2. So 2 is the first even integer, 4 is the next one, 6 is the next one. See? They all equal 12, so it fits in with the 6 times the original, and we have our 3 consecutive integers. See? So that's how we find consecutive integers, and that's how we find consecutive even or odd integers. All right? So we're going to move on to our next topic. 7.3a is our next video. We're going to talk about the distributive property and solving linear equations. I hope this was helpful, and I'll see you next video. Bye.